Uniform convergence and integration theorem. Let alpha be a monotonically increasing on closed interval AB. Suppose Fn belongs to R alpha on closed interval AB for n equals to 1, 2 and so on, and suppose Fn tends to F uniformly on closed interval AB, then F belongs to R alpha on closed interval AB, and integral a to b of f d alpha equals to limit n tend to infinity integral a to b of fn d alpha. Now proof. Let epsilon is greater than 0 be given. Let us choose neta is greater than 0 such that neta into alpha b minus alpha a is less than epsilon upon 3. Equation 1. Since fn converges uniformly to f, there exists a positive integer m such that modulus of f of x minus f of x is less than neta for all values of x belongs to closed interval AB. Equation 2. Since fmx belongs to R alpha on closed interval AB, there exists a partition P equals to A equals to x0, x1, x2, so on xn equals to B of closed interval AB such that upper sum of partition P function fm alpha minus lower sum P fm alpha is less than epsilon upon 3. Equation 3. Now the inequality 2 may be written as minus neta is less than fm x minus f of x is less than neta, which implies minus neta minus fm x minus f of x is less than neta minus fm x, which implies neta plus fm x is greater than f of x is greater than minus neta plus fm x, which implies fm x minus neta is less than f of x is less than fm x plus neta. Equation 4. Thus from 4 we have fm x minus neta is less than f of x, which implies fm x is less than f of x plus neta, so which implies lower sum partition P from fm x alpha is less than equal to of lower sum P f alpha plus n in neta into alpha b minus alpha a. Then by 1 we have lower sum P fm alpha minus lower sum partition P function f alpha plus epsilon upon 2. Equation 5. Similarly, f of x is less than equal to of fm x plus neta, so which implies upper sum P f alpha is less than equal to of upper sum P fm alpha plus epsilon upon 3. Equation 6. Adding 5 and 6 we get upper sum partition P function f alpha plus lower sum partition P function fm alpha is less than equal to upper sum partition P function fm alpha plus lower sum partition P function f alpha plus 2 epsilon upon 3, or upper sum partition P function f alpha minus L lower sum partition P function f alpha is less than equal to of upper sum partition P function fm alpha minus lower sum partition P function fm alpha plus 2 epsilon upon 3 is less than equal to epsilon upon 3 plus 2 epsilon upon 3 equals to epsilon by the 3, which employs upper sum partition P function f alpha minus lower sum partition P function f alpha is less than epsilon. It follows that f belongs to R alpha on closed interval AB. It proves that the first result Now we shall prove the second result. Since f and x converges uniformly to f, therefore epsilon greater than 0, there exists a positive integer m such that n is greater than equal to of m x belongs to closed interval ab. Modulus of f and x minus f of x is less than epsilon. Equation 7. Then for all x belongs to closed interval ab, for n is greater than equal to of m, we have integral a to b of f of x, f of d alpha minus integral a to b of f n d alpha is equal to modulus of integral a to b of f minus f of n d alpha is less than equal to of integral a to b modulus f minus f n d alpha is less than epsilon integral a to b d alpha by 7. So less than equals to epsilon alpha b minus alpha a is less than epsilon, so which implies integral a to b of f and d alpha converges uniformly to integral a to b f of d alpha over closed interval ab. Hence integral a to b f d alpha equals to limit n tend to infinity integral of a to b of f and d alpha.